The success criterion for this lesson is, I can use the work energy theorem to solve real-world problems. All right, so we're going to work some examples here. So example number 1 says, a student wearing frictionless roller skates on a horizontal surface is pushed by a friend with a constant force of 45 newtons. How far must the student be pushed starting from rest so that her final kinetic energy is 352 joules? All right, so we're going to use the work energy theorem here, which says that work is equal to the change in kinetic energy. So our change in kinetic energy is equal to the final kinetic energy minus the initial kinetic energy. So our initial kinetic energy, KEI, is equal to 0 joules because the velocity is 0. So velocity equals 0, initial velocity equals 0. So for that reason, the kinetic energy equals 0. Our final kinetic energy is given to us in the problem. It is 352 joules. So 352 joules is our final kinetic energy. So we want to know how far must the student be pushed to come up with enough work to create a final kinetic energy of 352 joules. So remember that work is equal to force times distance. So we have, if we expand that and put that and replace this with for work here, we have force times distance is equal to 352 minus 0. Okay, so we force we know, so we have 45 newtons times D is equal to 352 joules. So to find D, we got to divide both sides by 45. Let's move this over here. So we then have D is equal to 7.8 meters. So the student has to push their friend with a force of 45 newtons, 7.8 meters, to have them have a kinetic energy of 352 joules. All right, example number 2. So we have a 75 kilogram bobsled is pushed along a horizontal surface by 2 athletes. After the bobsled is pushed a distance of 4.5 meters, starting from rest, its speed is 6 meters per second, and we want to know the magnitude of the net force on the bobsled. Okay, so again, this is a work energy problem, energy theorem problem here. So we know that work is equal to force times distance. Kinetic energy is equal to 1/2 mass times v squared. So if we look through the problem here, we have mass, we have a velocity, we also have a starting velocity. So starting from rest, so that is our initial velocity. So VI is equal to 0 meters per second. 6 meters per second is the final velocity. So that's 6.0 meters per second. So we've got an initial velocity, we've got a final velocity. So our initial kinetic energy is going to be 0 joules. Our final kinetic energy is going to be 1/2 mass times velocity squared. So that's 0.5 times our mass of 75 kilograms times our velocity of 6 meters per second, and we'll square that. And so that's going to give us a kinetic energy of 1,350 joules of kinetic energy. So that's our final kinetic energy. And we want to know, in the end, the magnitude of the net force on the bobsled. We have a distance here of 4.5 meters. Okay, so we have force times distance is equal to our kinetic energy of 1,350 joules. So we know our distance. So we have force times 4.5 meters is equal to 1,350 joules. So divide both sides by 4.5 meters. And we end up with a net force of 300 newtons. So it takes 300 newtons of force over a distance of 4.5 meters to get the bobsled up to 6 meters per second. All right, final example, example number 3. A 700 Newton cliff diver drops from a cliff 20 meters above the water surface. Find the diver's speed 10 meters above the water surface. Then find the diver's speed just before striking the water. Okay, so another work energy theorem problem. Okay, so we have a force. That's the cliff diver's weight, so 700 newtons. We have a distance. We have two distances. So let's start with distance 1 of 10 meters. And we have a second distance of 20 meters. That's the distance just before the diver hits the water. Okay, now we know that work is equal to kinetic energy. So we know that work is equal to force times distance. So if we say work 1, it will be the work done on the diver by gravity at distance 1. So we'll say 700 newtons times 10 meters. That gives us 7,000, should be joules, not 7,000 joules. That's the work. And that is equal to 7,000. That's equal to kinetic energy as well. So 7,000 joules of work is equal to 7,000 joules of kinetic energy. So we know that kinetic energy is equal to 1/2 mv squared. So if we're looking for V, we can solve for V by multiplying both sides by 2 and then dividing by m and then taking the square root. So we have V then is equal to the square root of 2 times the kinetic energy divided by the mass. So we have the square root of 2 times 7,000 divided by now the mass of our cliff diver. So the weight of our cliff diver is 700 newtons. To get the mass, we divide 700 newtons by 9.8 newtons per kilogram or meters per second squared, and that will give us the cliff diver's mass. So the cliff diver's mass is 71.4 kilograms. So we have 71.4 kilograms. So the cliff diver's velocity at 10 meters above the water is 14 meters per second. All right, that's how fast the cliff diver is going at 10 meters above the surface of the water. So now let's figure out their velocity just before striking the water, which is basically 20 meters above 20 meters. Okay, so now we have work 2 is equal to force times distance 2. So that's 700 newtons times 20. So that's equal to 14,000 joules. So now we use the same formulation, since 14,000 is the work and that's also equal to the kinetic energy. We're going to use the same equation to solve for velocity. So we have velocity is equal to 2 times the kinetic energy. So 2 times 14,000 divided by the mass, which is 71.4 kilograms. And that gives us a velocity of 19.8 meters per second. Keep asking questions, everyone. It's how you learn new things.